Now recording. Good afternoon, class. How are we doing this evening? Afternoon? Doing well? Good. Exams are coming. But not for this class. Yay!
Yeah.
Everybody's max relaxed. Yeah? No? Everybody's worrying about data structures and algorithms. Well, if our class ends a little early today, I don't mind, answering a few questions on that topic, which is also a topic I'm somewhat knowledgeable about. So, assignment 6. Assignment 6 is the portfolio. If you all recall, we gave ourselves a good, decent chunk of time to work on the portfolio. I'm sure everybody's been working hard on it that whole time, right? At the very least, hopefully you've had some time to think about it, plan it, put it together, right, in your head conceptually, even if you haven't started programming yet. So that one's due Sunday. I'm very interested to see your submissions. Again, please try to make these of a quality that you would put them before your employer, potential employer. That's the purpose, right? I will give you good critical feedback on them, which, otherwise, I probably wouldn't have time to do for so many students. So, good critical feedback on application material, come on, yeah? It should help a little bit at least. So, I'm definitely, I was at I think it might have been last week, there was a program of study committee meeting, and I was talking to them about the JavaScript course, and basically my position with Kevin is that I'd like to take this course and pick its bones a little bit and, take some of the nice tasty morsels and put them in courses lower down. This is basically two approaches, right? One is to take this course whole cloth and stick it in second semester where it won't fit, right? Or you kind of pick topic by topic what's important and put it where it belongs. And I think the portfolio assignment probably would be manageable as a first assignment in JavaScript. You should know enough HTML and CSS to be able to accomplish it at that point. The portfolio shouldn't really require too much JavaScript, at least as an initial draft of it, right? So it's kind of, I think it's hitting a couple of good points. So, that's a change that I think I'm going to make in the future. I think that'll be beneficial. So no new assignment this week because you guys are working on that one. Okay? I know that there are ostensibly this many assignments, and that's 2 versions, okay? But I think we might be able to do 10. I don't think we'll be able to run the whole gamut. If I had to pick one, we're also not going to get to the pair programming material in that week. I'll publish it, of course, so that you guys can you have access and directed to it if you ever want to go through it. But I'm thinking assignment 11 will be one that we do next week, and then that'll be it. Assignment 11, basically this would be skipping assignment 10, but honestly, you are all in for a treat today, because today we are doing something that is of very, very highly practical import. Today we're going to be doing CI/CD and talking about DevOps, which is, words that appear on job descriptions, right? To some extent, the part of the intention with this class is to have it be a kind of plug the gaps, the keywords on the job descriptions kind of class, right? So CI/CD though, like properly understood and absorbed, will completely revolutionize the way that you develop software. As with a lot of things, it's like, would you go to all of this trouble for a single person project? Maybe not, A single person doesn't really need to coordinate with anybody else. But this is certainly like stuff you'll be expected to know how to do down the line. Okay? All right. So, I'll publish both of these guys. And next one as well. There we go. There, course material for the rest of the class is now published. So, let's kick things up a notch. Grown. Sir, it's too early in the morning for a joke like that. But it's 3:30 in the afternoon. Yes. So, continuous integration and continuous deployment. So, over the last, it's kind of been one of the running themes throughout the second half of this course. We've been talking about how to make the software development process less onerous for groups of people, right? Now, part of this has been the architecture of the software itself. Part of this has been the tools that we use to develop our software, and part of it has been the practices that we have, the practices we undertake, our practices, there we go, while developing software, tools and practices, if you will. So, the bigger a project gets, the more time people spend in meetings rather than actually coding. This is obviously suboptimal, as work is being done while you're coding, and work is only sometimes being done when you're in a meeting. So, not to mention, if you are a programmer, you probably went into programming because you like programming, right? You enjoy the activity, and the more time you spend not programming, the less sort of life satisfaction you have, right? Because you're not doing the thing that you got into the thing for, that you're passionate about. Instead, you're listening to, you're listening to people talk. And once again, it's a discipline that's notoriously full of introverts, and if there's one thing we hate, it's people. Especially when they're talking. So, of course, there's all kinds of stuff that's not programming that we typically do as developers, and a lot of it isn't getting stuck in meetings. Testing. Unit tests, integration tests, code review, I would include under this category as well. Deployment. Deploying to test servers, production servers, testing things on test servers, testing things on production servers, making sure things work the way that you intended to, filing the bug tickets, right? These are all things that we will have to do in our careers. Enter DevOps. Does anybody know what DevOps stands for? Development and operations, yes. So the idea is the actual programming is development. All of the other stuff is operations. The idea, like the central nugget behind DevOps, is we take an integrated approach to development and operations. We try to marry the two together. A way that this often gets stated, like operations also includes some stuff that we would consider networking stuff. So, like, in terms of like the actual roles that a DevOps engineer would have in a, in a company, you are talking about things like virtualization and containerization. You're talking about, stuff to do with the cloud. Stuff that networking, like here in this school, we have a bit of we consider networking to be a separate sub-discipline from software development, right? But DevOps is increasingly kind of stitching the rough edges of the both of them together, right? This is kind of part of the purpose. Properly conceptualized, DevOps, like you can consider DevOps to be the next iteration of a software development lifecycle. So it exists in the same category of things as waterfall method and agile programming, right? It's an approach to software development as much as it is the particular tools involved in the DevOps tool chain, right? Does this make sense so far? So, yes. The process involves both software development and IT operations. For example, implementing a new feature would fall underneath software development. A bug being discovered and handled would fall under IT operations. But DevOps seeks to marry these into one position. DevOps integrates and critically automates the work of software development and IT operations as a means for improving and shortening the software system's development life cycle, pardon me. That is the Wikipedia definition. DevOps is a field that's definitely still evolving, although, it's kind of like any one of these processes, right? You have the hypothesis, right, of this would be an interesting and cool way to approach things. You have the implementation. That's where we are now, right? DevOps is absolutely an implemented thing. What we are currently undergoing is the process of, the good features rising above the less useful features of DevOps. We're kind of trying to separate the milk from the cream, right? With respect, and that's a process that only occurs by actually using DevOps in practice in industry. You find out through practical experience what elements of it are good, what works, what doesn't work, right? At the moment, one of those particularly good dollops of cream which have risen out of the milk is CI/CD. A lot of people at the moment, almost use the term CI/CD as being synonymous with DevOps, although that's not quite true, right? But that seems to be the trend, right? So, DevOps essentially recognizes these operational and coordination costs and seeks to speed up development via automation and better alignment between dev and ops. There was a time, in the not too distant past, that software development was becoming disconnected from the tools and software which support that development. This is actually this is testified to by the very existence of the course you're taking, right? The fact that we need a specific course specifically for tools and practices means that software development has to some degree become divorced from such concepts. If these concepts were integrated into the courses, like at the level of the individual courses, there'd be no need for a course like this one, right? But once again, I want to congratulate all of you, pat yourselves on the back, because you've selected one of the correct electives. So, DevOps is a large and general field made up of many different topics. Roles and culture also fit under DevOps. As I said, in some degree, DevOps fashions itself as the successor to Agile development. So it's not only a method of development, but it's a method of organizing a company, right? But one very popular practice that's often used as a part of DevOps is CI/CD. This is automation, the automation end of things. So you may be asking yourself, right? Bash scripting is kind of a weird little side language. Can't imagine people use it very much, right? Right? Well, my ever faithful Stack Overflow Developer Survey for 2025. Right? Fine, I'll take the cookies. Good grief. So let's do this for professional developers. Although there's actually almost no difference between professional and non-professional in this respect, but let's see. These are the most popular programming languages, according to a very recent, very good survey. JavaScript, HTML, CSS, not a programming language. SQL, not a programming language. TSQL is a programming language, but that's not the same thing as SQL. Python, that is a programming language. And oh look, Bash/Shell. 5th place. 3rd place if you discount the ones that aren't programming languages, right? Neck and neck with TypeScript. But TypeScript kind of also doesn't count because it's like layered on top of JavaScript, so I don't know if you would count it as it's it's its own programming language, but it's not its own ecosystem, but anyway, Bash scripting. Why is Bash scripting so popular? Yeah?
To automate processes?
To automate processes, yes. So the whole point of all of the shell scripting that we've been doing, right? The whole point of dragging everyone in this class kicking and screaming through using the command line interface, if you type it into the command line interface, you can put it into a script file, right? And if you can put it into a script file, you can call it from another process. That process might be executing autonomously, automatically, right? So anything you enter into the command prompt, you can get a computer to do for you, possibly at regular intervals. Automation, right? I would say that this is an indication of how much of the coding content that developers do is process automation of the other ones, right? Like you can like use Bash as like a regular programming language, but it's not what it's good for, right? If you're writing a program that would be better as a Python program, you should do it in Python, right? Yes?
Do you think that this survey is saying that 48.8% of people actually write like script files, or do you think it just means they use the terminal?
Which programming, scripting, and markup languages have you done extensive development work in over the past year, and which do you want to work in over the next year? So this, to me, I don't think this selects for this. Like this doesn't. I don't think this could be easily like sort of manipulated into do I use a command line? Because it's speaking about it specifically as a scripting language. So yeah, I think there are like other areas, like there are other areas in here that answer some of these types of questions a bit more. Like I would say, sort of loading on, what would be loaded on top of, like simple use of a Linux environment would probably be more suggestive of I use CLI for stuff than just, you know, I use bash scripting for scripting, you know? And you can see, you thought that, you perhaps thought that like Linux wasn't, you know, we kind of have this myth about Linux that like almost nobody uses it. But if you take a look at the numbers, almost as many people are using Ubuntu as use Mac OS.
I think if you scroll down, it says Linux non-WSL, so I think that is specifically WSL Linux.
Well, but then Linux according to WSL is given here, so Pop OS, give me strength. All right, but anyway, that's just you know. It certainly seems that Ubuntu, Mint probably loads in here. I'm not sure that they disambiguate Ubuntu from Mint in these things. But yeah, lots of people use Ubuntu not only for personal use, but also professionally, right? Pretty big percentages. But anyway, so yeah, some of the stuff in this is going to blow your minds. So CI/CD is when we combine the practices of continuous integration and continuous delivery or deployment. So what the C in continuous means is that rather than having to have someone do a code review, read the code, push a button to, you know, say, yeah, okay, this is good, I accept the pull request, on we go, right? Basically, it's attempting to automate some or all of this process, right? Instead of having a person review code, we run automated tests on it. We can, spoilers, accept or reject incoming commits based on whether they pass or fail automated tests, right? So imagine you're at a company and the guy in the cubicle next to you, a certain Dorkly McCant code, right? Takes the repository, makes his branch, tries to push some syntax errors, right? There is, without this kind of stuff, if a person pushes syntax errors to main and they have permission to do so and they don't follow the appropriate processes, oh, looks like our main branch is now contaminated with a bunch of syntax errors and we just lost 30 or 40,000 clients, right? Maybe an exaggeration, but depends on how long it's down for, right? The repo itself can check things. We can run tests within the repo itself to reject bad commits. That is the soul of continuous integration. Continuous integration testing, right? You guys have passed or you have taken the software quality and testing course? Well, then you'll have done some of this. I'd like to teach that course at some point so I can see what they actually teach in there. But yeah. So if you've heard this before, just say next slide, please. So it's not only this though. The approach also requires a greater degree of integration with the whole, right? So one of the dangers that we can fall into with branches is that, I opened up a branch for a feature, and that branch is, I opened that up in I opened it in July, and it's now October, and I'm still ironing out some of the wrinkles, you know how it is, And it's like, well, that developer is now stuck in limbo, right? And the longer that goes on, the more and more that branch is becoming out of sync with the rest of it. It is much better to bite off a smaller chunk and get it done quickly and then integrate it back in, right? This is the idea of you are trying to continuously integrate changes into the main branch, right? Small branches, small chunky branches, right? So, the project, yes, I already mentioned that. So, continuous delivery is the practice of ensuring that software can be released at any time. Again, automation is part of this. Perhaps packaging the software up into a form which it is able to be released in. So, a thing that people like is pre-compiled binaries, right? When you're working on a software project, not everybody wants to check out the Git repo and compile it from source, right? Some people want pre-compiled binaries. I am guilty on some occasions. Whenever anybody wants me to check out the Git repo for software, I'm like, do I have to? Can't I just download it, please? But, in a world before CD, someone had to take the source code, hit compile, take those files, push them out as a release, and that was how you released precompiled binaries. These days, we have automation for that. If it's just a matter of compiling the file, do you really need a person to do that? Basically, that phrase right here, right there, that's the soul of DevOps. Do you really need a person to do that? Right? If the answer is no, if the person could be replaced by a bash script, then you should do so. Make sense? Any questions so far? Okay. So, continuous deployment is the practice of deploying software through automation, i.e. pushing the releasable software to the production server. You can imagine, you know, I talked about in the case where you're like downloading a precompiled binary, but if your product is a website, automating the transmission of an update from your, you know, your testing environment to the actual production server, making it so that it's not a person like sitting there pulling a crank, right? That is also part of continuous deployment. So, CI/CD is used together as part of, that seems like it's not a sentence. CI is also a swiftly evolving sub-discipline, but of course, this is software, everything is constantly evolving swiftly, right? You'll find some overlapping and still slightly contradictory definitions of things online. Basically, like this is part of the problem with software development and finding names for things. It's like, okay guys, I have this idea of what DevOps is, and it's this. And this person's like, I'm going to misunderstand what you think of as DevOps, and I'm going to do my own version over here. And I'm going to call it DevOps too. It's like, oh, well, I'm a third person, and I think that DevOps should include this and this, so I'm going to intentionally warp the definition so that it includes things that it didn't include before. And that's, you know, basically, you know, the software community is a bunch of squabbling, bickering, you know, people who can't decide on the definitions of things, and that's why it's frustrating to present slides on it. It would be much easier if I were teaching something, you know, something concrete like civil engineering, but you know, so it goes. Yes. Continuous security is a thing people sometimes try to integrate into it. I have seen people attempt to produce the acronym or the contraction DevSecOps, where the sec stands for security, because people don't feel that security is talked about enough in software. I think it's probably less talking, more doing, I think, with respect to security. But over time, consensus will emerge. So, here is an example of a typical CI/CD pipeline. We have our application code written by a blue hamster. This application code is pushed using Git to our source code repository. From there, it is built and tested, and then using integration testing, and then deployed, staged, some quality assurance is run, and then to the production environment. Yes?
That blue hamster is actually, I think his name is Gopher, and he's like the mascot for the Go programming language.
Oh, there you go. Interesting. The Gopher programming language?
The Go programming language.
Oh, Go, because he's a gopher.
Yeah.
Oh, man. Well, it shows you how much I know, how much I program in Go. Huh? Okay. I mean, it's kind of intentionally ugly, isn't it? It's got like, all right. If your mascot design includes pupils, which appear as black dots on the surface of the sphere of the eye, you're going for intentional grotesqueness as your like design ethic. So, okay, all right, sure. Thank you for that. Here's another example. Yeah, sorry.
I had a question about the testing. I've seen like some testing positions like online and LinkedIn and stuff, and I was wondering with what we learned here, it's like a branch that we could go into, right? It's more just like putting more time into, because there's like specific departments dedicated to testing in like different companies, right?
I mean, it's difficult to say without seeing the job description itself,
Yeah.
but I would say that like in the year 2025, if you're applying for a testing position, you should certainly have some kind of a handle on this stuff and have used it before. Like, yeah, generally speaking, like, yeah, it's like a position in a testing department. It's like, you know, you can't, it's like, how do you do a personal project that hits that, right? It's difficult. So you kind of just have to show, I guess, like some good general programming skills, and, you know, I've used this before, I've used that before. Taking courses like this probably helps. Testing, like, I've said it before, I'll say it again. It's a traditional aspect of software development culture that the road to senior development runs through the testing department. So I don't know how much like hiring of like direct new graduates a testing manager is going to want to do, or if they're going to want you to like kind of prove yourself as a junior dev for a couple of years, and then, you know, if you show promise, we'll see if you can hack it in testing, right? Something like that. I don't know, like when these positions are posted, like what do they like cite how many years of experience they want, stuff like that?
I don't really remember, but usually they ask like for 1 or 2 years of experience.
1 or 2 years of experience, yeah. So yeah, it sounds like they're kind of like, you know, get your foot in the door and, you know, like you can sometimes argue personal projects into counting towards years of experience, but they have to be pretty chunky, right? You should probably see commercial deployment of the whatever your project is, right? But yeah, 1 to 2 years is pretty low. I imagine you probably don't see many job positions that are asking for no years of experience, right? But yeah, I mean, this might also be a further manifestation of the great AI meme of our age, which is we laid off half the developers but had to double the size of the testing department. You know, perhaps this is a manifestation of that, right? They genuinely need more testers than they had previously, and you know, if they're like, when you need more of someone and there's not like quite enough people in that role to like fill that requirement, you kind of have to like lower your expectations about how much work experience someone has coming into the role, right? But I don't know if that's helpful, but that's pretty much everything I have that's intelligent to say on the subject. Yeah. Good question though. I love how like people in this class actually want jobs. There's less of a, you know, my dad made me major in this kind of vibe, you know. So here's another diagram of basically the same thing. Imagine the following, right? We have a software project. We do our development work, commit our change. The commit itself triggers a build of the software. That build occurs. We then get notified of the build outcome. Why would you need to be notified of the build outcome? Well, if there was a syntax error and it failed to build because of the syntax error, you need to be notified of it, right? Assuming you get past that, we can run some tests, get notified of what the test outcome was, deliver build to the environment, and deploy where necessary. Here's another business infographic. So, both agile and waterfall methods have the inherent flaw that they assume that a project may at some point end. But as we all know from experience, software projects never die, they are only abandoned, right? So, you often see this diagram of either DevOps or continuous integration and continuous deployment represented as the infinity symbol, because infinity is the amount of work that you are taking on by going into this discipline. Ha 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 ha. More jokes. So, let's start here. We do some planning, we do some coding, we build the code, test it, release it, then we deploy it, we monitor operations, we pick up things that need to be fixed, changed, adjusted, bug reports happen, no plan ever survives first contact with reality, right? So the plan was bad in ways that we didn't anticipate. The monitoring tells us how the original plan was bad. So we use the monitored data, update the plan, and go back into the loop of coding, building, testing, releasing, deploying, operating, and monitoring. In this manner, we continuously improve the product over the course of, the lifespan of the product. Make sense? So far, so good? It's kind of interesting. I have a slight comment on this. This is how people expect video games to be developed these days, right? Like they expect to be. I think Minecraft might be responsible for this, but like the expectation now is I want to pay like $20 for your game in like 2012, and I want continuous updates for like the next
10 years.
at least, like I think Stardew Valley is like over a decade old now, and that thing is still going, right? It's still in active development by one guy, right? And like, don't get me wrong, because he's been working that game for a decade, it's now like a decade of development's gone into it, and it's among the best video games, like indie games. Like it's among the best indie games, right? Like it's popular because it's good. Video games are kind of an interesting market because they're often popular because they're good or because they've had a bunch of marketing money dumped into them. And so if there's been no marketing, you know it's popular because it's good, But yeah, like, Minecraft also occurs on this model, right? And it's just, will Minecraft ever be finished? Will Minecraft ever be complete? Right? It's ridiculous to assume so, right? Good gracious me, Minecraft has been around for what, 20 years now? Right? And in active development that whole time? And somehow they've managed to not break it in all that time? At least not too badly? Well, people will argue with me about that, I'm sure. But, the thing that they did to break Minecraft was to sell it to Microsoft, of course. But yeah, like this is what people's expectations are now, right? it's like, you know, try releasing a standalone app that you consider finished. I dare you, right? The market will reject it on the basis that it's not getting updates, right? And it's like, well, I just want to, you know, I just wanted to write a pinball game and call it a pinball game and move on with my life. I didn't want to be stuck in this eternal hell of having to improve this one pinball game, which wasn't very good in the first place, for the rest of my life. You know, it's like, for marginal profit, it's like, well, you know, guess you should have read the room, right? So fundamentally, CI/CD is an attempt at addressing the rising cost of coordinating large software projects via automation. We are going to discuss GitHub Actions. GitHub Actions. So you know how in this course we're basically going through a bunch of the tabs at the top of your GitHub repo in the order they occur at the top of your repo? Well, we've gotten to the Actions tab. GitHub Actions can be used to perform CI/CD automation, though strictly speaking they're not limited to CI/CD. A big advantage of them, of course, is that you know that big popular tool everybody's using to organize the repos? Well, it's already there. You don't need an external tool for it. Absolutely, there are other tools that do this type of work, right? Maybe you're not in the GitHub ecosystem. It's possible to not be in the GitHub ecosystem, right? There are other tools. Jenkins is a big one. So, we could in fact do an entire course on DevOps, cloud deployment, GitHub Actions, all of the various tools. There are like some institutions where you can now do like graduate certificates in DevOps and that sort of thing. I was looking into this a year or two ago because I had been, like, one of the things I was kind of brought into the faculty to do was to like create a DevOps stream inside of a bachelor's degree program that the department is trying to cook up, like Bachelor's of Computer Science. And so I did a fair amount of like research, and I wrote a bunch of course outlines specifically on, like, you know, in this semester we would cover this and this, then that and that, and I had like a whole, 8 courses that would cover most of the main topics of issue for DevOps. But of course the problem is that the situation shifts so rapidly that those courses like would get stale. Like if like I wrote these course outlines last year, but by the time students are actually taking the program, it might be 5 years after those outlines were even written. So the course that would be on offer, would be out of date according to like, and you don't have to worry about that, but just like, I can attest to this, the truth of this. Like, there's a lot going on in DevOps, and DevOps engineers, I think, make the most money at the moment, versus like DevOps people make more money than software developers. So, and they make more money than networking specialists. So, it's generally considered like a rare, like a DevOps person is like normally someone with like 5+ years of experience. So, they'd love for us to be able to like crank them out with a bachelor's degree, but like, it's kind of like, maybe it's possible, but anyway, we're just going to learn about the core concepts of CI/CD, but we're actually going to do it in GitHub today. So, in GitHub, we have a thing called workflows. A workflow is a YAML file. You guys know what YAML is? Anybody know what it stands for?
Yet another markup language?
Close.
Okay.
It used to be called yet another markup language. It's now called YAML ain't markup language. Yeah. It's a recursive acronym, just like PHP stands for PHP Hypertext Processor.
Doesn't wine, like the, like on the Linux thing, doesn't stand for wine, it's not an emulator or something like that?
Probably. Yeah. Oh man. I'll tell you a story about wine after class. So basically, a workflow is a YAML file where you kind of set up an event and a couple of, you set up a trigger and you set up some things to execute after that trigger executes. And you may be asking yourself, okay, executes how? Executes on what? Right? But one of the things we're going to do is a workflow that triggers when somebody tries to push something into the repo, right? Events are some specific activity in a repository that may trigger a workflow to run, pull requests, pushing commits, opening issues, things of this nature. Runners. Runners are servers that run the workflows when they've been triggered. So, this is what it does. This is what GitHub does for you. You should send the thank you letter. When a workflow triggers in GitHub, the GitHub server opens up a little virtual machine, probably Docker containers at this point. It runs that script inside of a virtualized environment, and then it gives you the output. Very, very useful. Each workflow runs on a fresh, newly provisioned machine, like running the image for the first time. You can get Ubuntu, Windows, Mac OS runners. I am sure that you can get a very large number of flavors of Linux. It would not surprise me at all if Alpine was on there. You guys know what Alpine Linux is and is for?
It's like a really stripped down version that's meant to be as small as possible, right?
Yes. So Alpine Linux is it's a minimized version of Linux. It doesn't even have a GUI, right? It often doesn't even have bash. It has sh, just like shell, not even the born again shell, just like a little basic shell with many commands missing. But you can squeeze it in under 200 megs. And that's like Alpine Linux forms the basis of many, many containers, Docker containers. So, jobs are a sequence of steps done as part of a workflow. A workflow can have multiple jobs. Each step is either a shell command or a shell script, or an action to be taken or run. Steps of a job are run in order. By default, multiple jobs of a workflow can be run in order, but we can make a job dependent on another job to make them run in order. I think there's a missing not in that previous sentence. Yeah. For example, a job might have steps to build the application and then run tests. So you have to build the software before you test it. Those are two different jobs in theory. So actions are custom applications for GitHub applications that perform complex and frequently repeated tasks. You can create your own actions, or you can use pre-built actions or actions available in the marketplace of actions. Uh-oh, it's a product. It's a product being sold. So here's an easy one for you. Your virtual machine comes with almost nothing. Maybe you want to have Python on it so you can compile and run Python programs. Rather than having to compose all of the bash, right, all of the bash stuff to install Python on it, you don't know what the sudo password is for this VM that they've cooked up, right? You just use the action that installs Python and it installs Python, right? Another, you can also have actions that operate on the repo itself. So maybe you want to check out the repository into the virtual machine. There's an action for that as well. So, a scheduled internal or some event will cause a internal event or some event will cause a workflow. I'm finding the grammar in these slides a little trying. Will run on runners, executing a sequence of steps made out of shell commands, scripts, or actions to perform work. So for example, maybe we push to the main branch, and that causes a workflow to run in an Ubuntu runner, which checks out the repository and performs a unit test. These things are possible. So, yes. GitHub Actions are free to use for public repositories, and a certain amount of usage is allowed for private repositories. But, basically what they want to avoid is you just friggin' using their VMs for just running your programs, right? It's a service, it's meant for a certain amount of stuff, but, don't abuse the system, everyone, right? Workflows are defined as YAML files. YAML files should be stored in the directory .github/workflows. Aspects of the workflow are, like the name, jobs runner, job steps, etc., are defined using YAML key value pairs and lists. So, quick hint for YAML files. They are JSON, but with a lot of it's basically, if you take a JSON and you apply the Python treatment to syntax, you end up with YAML, right? So new lines are meaningful, whereas they're not in JSON. The curly braces are omitted in favor of things like colons and indentation, right? But essentially, we're still in JSON land. Make sense? Good. So, here's an example. hello-world.yaml. So, needs a name, so there we go. On push, this is where we specify what sort of event this workflow will trigger on. Jobs, give it a name, output hello world. Give it the name output hello world. Runs on, we say what virtual machine we wish to load for this workflow to execute on, or this job to execute on. We then have steps listed. Action checkout version 4. So we are checking out the repository, right? How are we to run the code if it's not in the VM, right? Run the script, echo hello world. Let's see if we can get that running, shall we? If everybody could please kindly open up, log into GitHub, we will do a live demonstration of using GitHub Actions. And, assuming you're not already logged in, there we go. I'm just going to log in myself. way. There we go. So, let's make a new repository, shall we? New repository. Repository name, actions. Example. There we go. An example of actions. There we go. Choose visibility. Let's make this public. No readme. No git ignore. License. Let's see. The unlicensed sounds pretty epic. That's not a good way to select a license, by the way. So, for the time being, let's just, we're just going for a hello world. So let's create our workflow file directly. Now, you may be saying to yourself, I'm supposed to put this in the .github/workflows folder. I do not see a means of adding a new directory. Well, my friends. Oh, and by the way, this is a thing you may not have known about Git and GitHub. If you put a directory into a repository, but the directory has no contents, it won't actually save it to the repository. Like, you actually need a file in the directory. So, create a new file. Let's name our file, .github/ see what it just did? Workflows / is it workflows or workflow? This is the type of thing that matters. Workflows. Make sure when you're doing this that you are matching the strings exactly. This is exactly the sort of thing that it's looking for, right? And now, let's call this hello.yaml. Let's see here. Is it? No, without the A. So, and it's like, I see that you are setting up an action. I see that this may be of help to you. Are you writing a Java program? Maybe we have something to sell you. It's like, nah, I'm just doing a hello world, thanks. But thank you for all of that. So, can I make that go away? Is there a go away? Documentation is less obtrusive, I guess. So, essentially we want to copy this material in here. So, name, hello world, on push jobs. So just a little bit on YAML syntax, right? In JSON, this would be an object, right? These are key value pairs, right? Output hello world. Name. Output hello world. Runs on. Ubuntu-latest. Steps. Uses actions/check out at v4. Giving myself carpal tunnel. Okay. Are you guys aware of what the correct orientation for a keyboard is relative to your wrists? Have you been taught this, like ergonomics?
Nope, I remember that in high school, but
Yeah,
yes.
okay. Okay, pretty much all keyboards that you will ever see are designed backwards, right? If you'll notice, they all have these tabs on the back side of them, the intention of which is to prop it towards you a bit. Although this does help you see the keys, it is not good for your wrists, right? You guys know what actually causes carpal tunnel? Do you know what the carpal tunnel is?
Yeah.
So let me bring up a diagram of the human wrist. The human wrist. There we go. Right. Carpals. Right? So you have this cluster of small bones in your wrist, which are called the carpal bones. These are metacarpals, these are the carpals. Inside of them, there's a hollow tube that goes between the bones, right? This is where the majority of your tendons pass through into your wrist, into your hands, and where like nerve endings and blood flow occurs mainly, right? So you may not have been aware of this, but there are almost no muscles in your actual hand, right? All of the muscles which control your hand and give it strength are located down here in the arm. Do you know why that's the case? Closer to the body, so it requires less torque to lift it. Makes the arm more efficient, right? So the carpal tunnel is the tunnel through the carpal bones through which your tendons pass, right? Now, what happens when you get carpal tunnel syndrome is that these ligaments, which control your fingers, if you have your wrist at a bad angle and you're moving your fingers like this, your tendons are actually rubbing up against, they're having friction with the bones on the inside of your wrist, right? It's not if you can take a certain amount of it, but if you're doing it too much, you end up with a degradation in both the tendons and in the wrist bone. But the tendons take most of the damage, right? So that's what carpal tunnel syndrome is, right? So how do you prevent it? You avoid use of your fingers when your hands are not straight in front. Like, if you're like this, you can use you can use those tendons as much as you like, but you try to avoid doing that with your wrists and trying to use your fingers, right? That's what causes carpal tunnel. So back to how keyboards are badly designed, right? If you have your keyboard at an angle like this, and some of them have even an angle like that, right? And you're typing like this, how am I having, assuming you're sitting, right? How am I having to hold my wrists? Sure, I'm able to rest my wrists on, the desk, but you'll see that that's how you're holding your wrists, right? Which means that you're causing yourself carpal tunnel syndrome. What is actually correct is for your keyboard to go the other way, right? If you take a look at what your neutral wrist position is with respect to a keyboard, it's actually facing down. This means you can't see the keycaps, so you can't see what, you have a less easy time seeing what keys you're typing, right? But this is why you're supposed to learn what the keys are. This is why you're supposed to learn touch typing, right? So you're supposed to have your keyboard angled down towards the computer. And that's pretty much every cheap keyboard that you've ever used has been giving you carpal tunnel for this exact reason. So, it is worth the investment, in my view, to get an ergonomic keyboard. although I give Microsoft a lot of stick, they do make a pretty good ergonomic keyboard, so that one's the one I use. I highly recommend it. The other thing, you know what though? It's like mice are also a big problem, right? So I'll show you the, I use one of those trackball mice, like one of those, yeah. Vertical trackball mouse. One of these silly things. Yeah, they're so nice though. Like they take a little getting used to, but once you're used to them, they're much faster than a normal mouse. Although, you know, I don't think you'll see the Razer version anytime soon. But yeah, I was during the pandemic. Actually, I was developing a course at the same time I was teaching it, which means I was writing a lot of slides, and I was doing so on a laptop with a laptop keyboard, and like I had actually developed a twitch in my thumb, and like I spent the rest of the semester in wrist braces, self-imposed. I never actually saw a doctor about it, but like I was in wrist. I kept the wrist brace on for like a semester, the rest of the semester, and that kind of. I didn't have to have surgery or anything, but like that's if you have carpal tunnel, one of the possible outcomes of that is that you have to have a doctor cut your wrist open and fix it. So ergonomic keyboards. Each one of you should have it because you are computers professionals. You are supposed to be using computers for a living. It's worth, like, you know, when you're a student, you're like, I'll make do with the cheap stuff. But at a certain point, you're like, I should be buying the right tools for the job, you know? It's worth the investment to buy the right tools for the job, you know? This is also true of like power tools and stuff, but you know. But yeah, anyway, what was I talking about? Oh yeah, this stuff. So yeah, and that whole rant was because like these keyboard trays are designed to be able to tilt back like that, but like people, like for some reason always tilt them forward because they don't understand how human biology works, you know? Good grief. So you may, why are you complaining? Yes, I did mean name. Thank you. So you'll see that, like, as we're doing this, GitHub itself is giving us a little bit of help. Like, it's like, oh, you're writing a workflow? Okay, well, you misnamed that, right? Commit changes. Boom. There we go. We have hello.yaml. Very good. Note that a commit from the web GUI counts as a push event. And we just committed a workflow that does something when push events occur. So, if we go back to the code page, there we go. Ooh, I'm not seeing it though. Oh, I gotta go in here. Do I have to go in here? Yeah. Oh, yeah, there we go, 1 minute ago. Open commit details. There you go. Create hello.yaml. You'll see that we have a little tiny check mark, which did not occur previously. What is this check mark? This is the workflow that was just executing successfully. But you may be saying to yourself, I expected a hello world. Where's my hello world? It's in the Actions tab. There we go. We have one workflow run, this workflow that we just committed. Create hello work.yaml. Took 13 seconds. Pretty good. If we take a look inside, there we go. You can see we get a detailed view of all of the actions that the workflow took, including setting up the job, checking it out, running the script. Here we go. Run echo hello world. There is our hello world, my friends. Our output. Very good. So we did actually run echo on a VM running inside of GitHub just now. Kind of cool, right? Cool. Now, yes?
Do you have any idea how powerful the little VMs that you can create in your workflows can be?
Well, I know that when these slides were written, it said wait a minute or two, and we just got it done in 13 seconds.
Right.
So, I imagine what has happened in the intervening time is that these things are now running in Docker containers, I would presume. I don't know that for sure, but I would presume. And that means that they're going to be spun up much more quickly, because, like, you know, you can imagine spinning up a Docker container versus spinning up a whole VM for this purpose, right? It used to be most of the time was spinning up the VM itself, right? But yeah, I mean, this is used for integration. This is used for testing and running the program that you're writing. So, what's the upper limit? I don't know. I've never tested the upper limit, but it's probably chunkier than you might think.
Yeah, so I'm wondering, for my capstone, I have to run, like I have to build my Docker container on my VPS, and I have a really cheap VPS, so it keeps like crashing halfway through the build process. So I was wondering if I could use GitHub Actions to build the Docker container and then publish the container to the server.
Ooh. Well.
I guess Docker would have to run inside the Docker container.
Yeah. I would be skeptical about the ability of these things to. I would be skeptical about the ability of these things to nest virtualization. I will say that, like, if you check, like, this is, you know. If you check a recent tutorial on GitHub Actions, it may be that you could just feed it a Docker file.
Okay.
Maybe. I suspect that might be the case, but this is kind of at the edge of my domain of knowledge. You're thinking about your wrists, aren't you?
I am.
Yeah. So, yes. So, you know, the slides have me like commit a new file, and then you can see it running again. So, you know, okay, we can do that. Plus, new file. I am the very model of a modern major general. Oh, needs a name. File.txt. Commit. Commit. There we go. Create file. There we go. If we go to the Actions tab quickly, whoop! Ah, it's already done. That one only took 8 seconds. Probably because it was like, this guy's probably going to need this container again, right? And there you go. Hello world ran again. That's the checkout. Post run actions. Run the script. There you go. Good. Okay. I kind of feel like that might be a good place to leave it for the break. You guys feeling breakish? Breaky? Yeah? Okay. Alright, we shall have our union mandated half-hour break. Please be ready to resume class at 4:20 or 4:22. 5:22. Thank you. So we got Hello World working. The next thing that we need to do is to run some actual tests. Now, I'm sure when you took the testing course, you had some kind of fancy program that you used. Well, here we are going to use diff. Just diff. We can use diff to compare the output of a program to the output of the program run previously. We can do this in a super lightweight and fast way that is suitable for working inside of one of these virtual machine environments. So, but to understand success versus failure for a GitHub workflow, we must understand exit statuses. I think this is probably something I talked to you about way back at the beginning of the course, but so let's review. All right? When a program is running inside of a bash shell or in a Unix-ish environment, information is communicated from a process in a few different ways. The most obvious one is standard output. The standard output stream. This is where we dump the text that we print while the program is running. Standard error, same as standard output, but for error messages. And one of the most important ones, although it's often overlooked, is the return status of the program. If we take a look at a C program, C is a good language for understanding these sorts of things. C, hello world. Boink, boink. There we go. Hello world in C. Is this correct? It appears to be. We include standard io.h. This is a thing most languages include by default. Int main. So the main function is the entry point for execution, in the same way that the main method is in Java. Int though, because if we recall from Java, let's ring it off for ourselves. Public, static, main. So void means it doesn't return anything, right? C programs return an integer. What is this integer it's returning? This is the exit status of the program, right? Return 0. This is what it does by default if you forget to return something from main, right? So how is this number interpreted inside of a Unix environment? 0 means exit status normal, right? Anything non-zero means I'm returning an error code, or I'm returning some kind of non-normal status, right? This is very old. This is a very old way of doing things. This predates exception handling, right? This is how you used to report errors to the execution, right? Make sense? When we're doing bash scripting, we can, in fact, we can ask for the return status of the last program to have executed. It's a special variable, question mark. This will give us the value of the, like if we say, diff A and B, this gives us the output of, the numeric output of the diff program aside from what it prints to the screen. In our case, we're not necessarily all that interested. It's good to record it for if you need to pick through it. We're primarily interested in, is this file different from that file, right? If this is the old output for the file, which we know to be correct, and this is the new output for the file, if it doesn't match, we broke it, right? And if we broke it, we should reject the commit, right? So, GitHub Workflows will reject if we have a non-zero exit status from one of our processes that's run inside of the VM, inside of the runner. All right? Now, another important thing, compilers will also return non-zero exit statuses if they, for example, fail to compile something. Right? So, if your program flunks out on a syntax error, blah, good grief. I just wanted to see hello world in C. Yes. So the diff command, we can use this to check outputs, right? If there are no differences, you get a 0. If there were differences, you get a 1. If there was some kind of error, we get a 2. So, let's consider how we change our run line in order to compare two files. We're no longer echoing hello world. We are diffing them. So let's pull up GitHub. Edit. Let's add a new one. Name. Diff output. Or check for differences. Run diff. We made a file called file.txt. If we compare it to itself, it should always be the same as itself. Commit that, saving, up. There we go. Let's, see, some checks haven't completed yet. In progress, the check has started. There you go. I did it fast enough. we go. Job complete. There we go. Did it run? Check for differences. There we go. No problems were detected. However, let's go back, make a new file, call this one file2.txt, enter file contents, the rain in Spain falls, Spain's kind of less. Spain falls mainly on the plain. Commit changes. There we go. If we modify this so that we're now comparing file 1 and file 2, commit changes, commit. There we go. Actions. If we go fast enough, maybe we'll see it executing. Yeah, see? We get a little spinny bar. Oh, we get a little X. Dun 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 dun. Process completed with exit code 1. You can see right there. There we go. So, most typically, we would perform automated testing of programs using some kind of package to help. For example, PyUnit when doing Python. These frameworks help to make automated testing easier, building in support for things like setting up and tearing down tests, defining tests, etc. But we don't really have time to get into using testing frameworks, and this lightweight approach using diff is surprisingly flexible and surprisingly useful. And it's an actual approach that is used in actual industry sometimes. Because keep it simple, stupid. Right? This is how it can work, right? You run a program. That program has its output captured in bash and saved in a file. You then can use that as the model to compare future output to, right? That's kind of perhaps a bit of a blunt mechanism, but yeah. We can create a txt file containing the expected output of a program, for example, expected.txt. We can run a program and save the output to a file, something like Python main.py captured as output.txt. Or, if the program writes things itself, you can also, name it something. We can then compare the expected output to the actual output using diff. If diff returns 0, our tests pass. If it returns 1 or 0, the tests fail, and GitHub will notify us of this. Right? So, yes. So, within the, if if it's okay, I think we're going to, I'm gonna do this in the slides, this one. Because I think we've demonstrated how and that it works. Hopefully that's good for now. Because we do still have the second topic to get onto today. So, going back to the root directory of our repository and clicking on plus, we will create a new file, a Python program called main.py, which simply outputs some output from the program. We'll then commit it, and make a new file in the root directory, call it expected1.txt, have it contain the exact expected output from the program, some output from the program. We can then commit changes. We can then go back to the workflows folder, click on add a file, and then create a new workflow. Call this autotest.yaml. Automated test on push runs on Ubuntu latest. We're checking out the repository. Then we actions set up Python version 3, right? This line will then install Python on the Ubuntu runner that has just had the repository checked out into it. We can tell it what version of Python we want as well. Then we want to run Python main.py and capture the output, right? This will capture the output into actual1.txt, and once we have actual1 and expected1, we can call diff on the combination of them, and this will tell us if the program outputted what we expected it to. Make sense? So you see these things can get quite, this is still pretty basic, right? Yes, I explained all of this already. Commit changes. There we go. If we wait and refresh until the yellow dot turns into a green check mark, we'll see that the workflow is all succeeded. We can click on details. So that's the other thing is if you have, I've been modifying the same file, but if you have multiple workflows, all of the ones that you say to execute on push will execute on push whenever you push something. You can have multiple, you're not restricted to just having one. So, we can see we can see the produced actual1.txt file by running the Python program. And diff found no differences. Very good. All right. Now for one that fails. We'll make an expected2 with different text, output that will not match the actual output. We commit those changes, modify the workflow so that we are testing expected versus actual 1 and 2. Right? I'd say running the Python process twice is probably redundant here, right? But so it goes. Yes? Commit. Here we have checks were not successful. So you can see that test 2, the output was different from what we expected, so the test fails. But this is with the program being compiled and run from, it's Python, so interpreted, right? We're starting with source code, we're executing the source code inside of the runner, and then comparing the output inside of the runner as well. Note that it's as if the current working directory when running Python is the root directory of your repository. So if we had a file called expected1.txt in tests in a subdirectory of the root, we would expect that to be in a subdirectory as well. This is helpful because we wouldn't normally want to keep files like this in the root of our repository. So file paths are a thing. On the actions page, if we click on new workflow, we can get a whole list of suggested predefined workflows, as well as the ability to search for workflows. If you thought, man, it would actually be really tedious having to write all of these myself, you're right. You know, this is kind of like almost an epitomization of modern software development. What are we doing, right? We are writing a program so that we can write a bash script that runs the program inside of a virtualized environment by itself embedding the bash script inside of a YAML file, right? Like, you know, how many layers deep does this go, right? But, you know, that's modern software development for you, or contemporary software development. So, in addition, GitHub has many actions such as checkout. You should check them out. When you edit a workflow file, there is a searchable marketplace of actions. We could also make our own, but that's well beyond the scope of the course. It's going to be very specific to whatever it is you're working on, right? Now, when all of you go into your capstones, all right, are your capstone projects going to be stored in Git repositories? Possibly GitHub? Yeah? Are you going to impress your professor by setting up, there is a, like, on the capstone there is a testing requirement, right? I wonder if you could meet the testing requirement of your capstone by setting up GitHub Actions to automate, test it in an automated fashion, right? I wonder if that might be useful and good job experience so that if you apply to a position that says, oh yes, we need people who know how to use CI/CD, and you show up to the job and they're like, okay, well tell us what you know about CI/CD. It's like, well, I use GitHub Actions to do automated testing on my capstone. It's like, that's a phrase that gets you a few points, right? Especially considering it's your capstone, and you could, in theory, just pull it out and show them, right? And that's a good, that gets points. That gets points in an interview, at least during the technical phase of an interview, right? Yeah, particularly, you know, if you're interested in landing a position in the testing department, you know, again, like, this diploma is just like anything in life. You get out of it what you put into it, right? So, there are, of course, alternatives to GitHub Actions. Circle, CI, Jenkins is a big one. Azure has its own version of this. GitLab has its own version of this. But, you know, if you're already using GitHub, then it's no additional work to install GitHub Actions. So, make sense? Any questions about this stuff? Run bash scripts automatically? Oh, by the way, if you don't want to do out every single, like, you know, if you don't want to do, like, 2 lines of YAML for every single bash command that you want to execute, just put it in a bash script, like an actual script file, and run that, and there you go. That's the way a pro would do it. You know you're like a software professional when you hear something like you look at a YAML file like that and you're like, oh, that just looks like a lot of work. All right, good, wonderful, fantastic. let us now discuss solid design principles. So this is another one where we're going to be talking about, design principles which we've endeavored to instill in you through many courses offered here at the college, but have never quite brought to such a fine point as to have actual slides on the actual topic. So, SOLID is an acronym. It stands for Single Responsibility, Open-Closed, Liskov Substitution, Interface Segregation, and Dependency Inversion. These are all aspects of object-oriented design. All right? These are things we are trying to accomplish in object-oriented design to have better object-oriented programs. So I want you to take your brains, all right? You have your brains? Yes? I want you to pick your brain up and put it into your Java head, all right? I want you to become one with the beans. You must become Java, right? Because we're talking about object-oriented. So, solid principles are a set of software design principles that apply to object-oriented design. Some principles are more general. They may apply in more situations, but I'm going to level with you. Every single language you've used so far is an object-oriented language. Anybody here programmed in Haskell before? Prolog? C? C is not an object-oriented language. It does not support objects. It is an imperative language. So, these principles are meant to be applied together. They are meant to improve system maintainability, modifiability, and extensibility. That's a lot of abilities. They are also meant to avoid bad code smells. You guys know what it means when code smells bad? It's like, I'll give you an example, all right? It may be a recent example from a certain set of videos I've been watching for a particular class I'm teaching at the moment. Perhaps immediately at the moment. If you're using cat as a multi-line editor, please stop before you hurt yourself. There is a reason that we have text editors. Cat is not a text editor. Cat is a program. It's like as bad as writing your bloody files in Echo, right? Don't write your files in Echo and then append each line as you write it to the file as you're going. That's not a way to make a file, all right? It's okay, you can use a text editor. Just because you told the AI this has to be done in terminal, doesn't mean that it has to be taken that literally, all right? Honestly, that is a bad code smell, all right? Let me tell you that the bloody chatbot has dropped some wicked, stinky stuff into my life over the course of this semester. And somehow, I'm not even sure that this is possible, but it seems like it's degrading, at pace with the course being offered. I think it's gotten worse since September in terms of the amount of crap that It's like, I thought it was bad enough when it was like teaching you all to use like sed substitutions inside of VI that you had no idea what you were doing. You were doing global replaces over the entire file and possibly destroying data. And then I saw it using cat as a text editor. And I'm like, okay, that's bad code smell, all right? Symptoms of deeper problems in a software system, all right? There's a biblical proverb, all right? Those who are faithful in little who will be faithful in much, but those who are unfaithful in little will be unfaithful in much. So if your code smells bad, if one line of your code smells bad, probably it stinks the whole way through, right? So, one way to make your code smell less bad, so that I'm not literally wearing a clothespin as I'm grading it, single responsibility. The single responsibility principle. A class should do one thing well. It should not attempt to do everything. If your class is attempting to do everything, it's probably multiple classes that you've smooched together. Right? So, a class should have responsibility over a single function of the software, and the class should encapsulate, remember that word, folks, encapsulate, that entire functionality. All services provided by the class should be narrowly aligned with that responsibility. Example, model view controller. Each of M, V, and C have very specific responsibilities within the overall web application, and it is a big O problem if they're stepping on each other's toes, right? I don't think I need to review for you what M, V, and C stand for, though. You guys have had that to death, I assume, by this point, right? Yeah. So, changes to the look and feel of the website, that is to say, changes to the front end, should not have an impact on the business logic. Like, one of the key skills that underlies all software development, which is very difficult to train in students, is the concept of separation of concerns, right? Like, it requires a very analytical mind to be able to do it consistently and thoroughly. And you can train yourself to think this way, but it requires training because, in your normie life, you're not going to think like this, right? In fact, in your normie life, it's probably disadvantageous to think like this. So, what separation of concerns means, if I have a piece of software and I need it to produce some output, can I take it and break it into modules? Can I take the modules, break them into classes? Can I take the classes, break them into functions? Can I take the functions, break them into individual operations, like broad scale? Can I take those operations and chunk them out as individual lines of code, right? Can I take a line of code and I kind of divide my work up within that even, right? At every stage of the software process, you are taking an abstract concept and concretizing it by drilling down and separating out what is this operation doing and what is it not doing. I will do what it is doing and I will not do what it is not doing, right? That is an absolutely essential skill in software development. And I think it's one of the things the AI can't do, right? The AI can only suggest to you ways people have solved the problem before, but it can't, like, we'll see how well it does, but I think it would struggle in applying an architecture to a new novel situation, for example, especially if it was a novel architecture. So, consider compiling and generating the data for a report and printing or formatting the report. If you have a class that does work on some data, it may be tempting to make a print method in the class, but should compiling and generating the data be tied to printing and formatting of the report? It may be better to have these functionalities in different classes. The more involved printing and formatting becomes, the more it should be considered a distinct responsibility deserving of its own class. So, here's a question. Can we architect software? What do you think? Can software be architected? We talk about software architecture, right? This presumes the existence of an architect. But it is a mistake to think of software as being analogous to some of the more formal disciplines in the applied sciences, right? Imagine if we had a structure such as the ever-beloved Space Needle. No, I'm sorry. Skylon Tower. No, that's not it either. The CN Tower. When they were building that thing, they took a bunch of concrete, right? They let it set, then they put more concrete on that concrete, let that set, and they continued that process until they had a giant spike, right? And then they put an observation deck on it, and then they continued the spike a little further, and there we have one of Canada's most famous landmarks, a bunch of concrete piled on top of itself. But let's say they got halfway up the tower and they decided, yeah, you know what, I think we need to make some changes down in lower structures, you know? So what are they going to do? Take all of the concrete, rip it down to the level that they wanted, you know, that they needed to make the changes at, make the changes, build it back up again? How many times do you think that, you know, whoever was paying for it, presumably CN, was going to allow that to happen, right? This is the difference, this is one of the fundamental differences between what we do and what everybody else does, right? We can rip things back, like we can modify the foundation, but the question is, should we, right? Like, I remember that this was a thing that my professors at the university used to complain about, because I actually did robotics engineering when I was an undergraduate, but I took a lot of courses that were combined with the software engineering program, and a thing that they would say about software engineering was like, our aspirational state is that people take us seriously the same way that they take civil engineers seriously, right? And what they've run up against is this kind of intractable problem that software development does not produce reliable results in the same way that a more established field of engineering does, right? If you need a chemical process done and monitored, and you need to have some hydrocarbons split, a chemical engineer can reliably split hydrocarbons for you. People who build bridges are really good at it. They can build a bridge from anywhere to anywhere, except if it's ridiculous, like to the moon, right? Software people, can we even, like, develop software? It's a question, right? sometimes the project works, most of the time it kind of works, and a lot of the time it fails completely. This statistic was like, it's a few years old now, but apparently half of all software projects fail. Right? And this is an opinion of some rando on the internet. You are not a software engineer. Well, I mean, you guys wouldn't be anyways, but you do not build skyscrapers. You do not build bridges. You grow gardens. You're a software gardener. I find that kind of silly myself, actually. The idea that we are gardeners. It is true that the software kind of grows in some sense. Like the point he's making here is like, if you employ a gardener, do you expect a certain number of flowers, right? No, you expect a vague idea of flowers to appear in a certain patch of earth, right? So we have, the vague idea that a certain amount of, functional programming code will appear somewhere in the vicinity of the money you've spent, right? Cope! That's cope right there. So, but this whole discussion leads us to one of our principles, which is openness versus closedness. So, the essential idea is that when we write a class, it should be open for extension, but not for modification, which is kind of strange because extension is a form of modification. So, language problems, equivocation in definitions. Ooh. You guys know what equivocation is? Equivocation is an informal fallacy where you're having a conversation with someone and they use a word to mean a particular thing, and then you have a good argument, and then they change the definition of the word as they're having the argument with you. That's called equivocation. And you shouldn't let people get away with it. It's the sort of thing extroverts try to pull on you all the time. So, anyway, entities should allow their behavior to be extended without modifying their source code, i.e. we don't change the foundation when we build on top of it. So, we can implement these ideas with inheritance and abstract classes and interfaces, but generally, the idea is if you need to add functionality, add a new class, and then maybe make a composite class of the class, the old class and the new class, make some kind of, union of the two and provide that as an interface rather than modifying the existing code. Modifying the existing code is a terrible, 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 terrible idea, and you should do it frequently. No. Modifying the existing code base is you're just going to break things. You have no idea where all of the dependencies are, no matter how helpful IntelliJ is, and you're just going to break stuff, right? When you wrote the API, people have used it based on the API's functioning in a certain way, right? You'll notice that when something is being deprecated, right, it's a big deal that something's being deprecated. It's like, this is being deprecated in 2032. They give you lots and lots of notice that something's going to be deprecated, right? Yes?
Is there a certain size of project where you shouldn't? You said don't go back and edit whole parts of your API or whatever. Because in my capstone, I'm probably poor designed by me, but I'm constantly going back and redoing how I did stuff.
Yeah, I mean, I guess the point of these slides is it would be better if you had like a solid plan to start off with and then just, did it and left it alone. That's like the ideal,
Yeah. Well, my issue is that I thought I had a solid plan to start out with, and then I started using it, and I was like, oh, this makes no sense. So I had to go back and basically rewrite the whole thing.
Yeah, trust me, I know. I had to do that same process 4 times. I had to like rip the beating heart and soul out of my capstone, my PhD, my compiler that I wrote for my PhD. I had to do that 4 times, and it took me 2 years to do it each time. So, yeah, I hear you. The problem is that your ability to code is dependent on your understanding of the problem you're trying to solve. And you don't fully understand the problem you're trying to solve unless you've had a couple of attempts at solving it. So yes. But I guess like the point of the slides is we're preferencing extension over ripping the guts out, modifying them. We can implement with inheritance, OCP, and have parent classes be closed for modification and child classes as extensions. You sometimes see things as being marked closed, right? This was how the principle was originally implemented before abstract classes and interfaces. We can also implement these with abstract classes, which can contain implementations of elements that will never change. Hierarchy of child classes can then deal with further extensions. So basically, if you use object-oriented principles, create the interface, reliably implement the interface, then you have something solid that child classes can use, right? So, advantages. Whenever we modify something that's being used, we very likely need to modify where and how it's being used as well. By never modifying this foundation, we don't need to change the code that is using it, right? But of course, you don't until you have to, right? And once you have to, you're back in the same boat. Abstract classes make this fairly easy to do from an implementation standpoint, negating any drawbacks in terms of added complexity. So, let us consider some parent-child relationships. This would be a very funny, out-of-context thing. If S is a child of T, a compiler will let us use S in place of T, right? You guys remember this from Java, right? This is one of the multiple forms of polymorphism that we covered in Java, right? But does that mean it's okay? Will the program output be correct because the compiler allowed us to do it? Of course not. Although the compiler allows it, the programmer would need to ensure that this behavior is okay in terms of its output. So, and this is where we get to the Liskov substitution principle, LSP. Here is the principle. Objects in a program should be replaceable with instances of their subtypes without altering the correctness of the program. This is going to get very mathy, so strap in, kids. This goes beyond subtyping. It's a form of strong behavioral subtyping. This needs to be a semantic rather than a merely syntactic relationship between types. You guys know the difference between syntax and semantics? Okay. Quick little bit of compiler theory for you then. So, syntax, hopefully we all know what is meant by syntax, right? You can actually formalize a programming language syntax as a form of grammatical rules, right? Syntax is grammar. In the same way that syntax is grammar in a language like English, syntax is a grammar in a language like Java, right? The same system creates a grammar in both cases. Semantics is the mapping of syntax to meaning, right? It's the mapping of symbols to their meanings, right? So if I say the word potato, right, there is a semantic meaning to the word potato. It is a large, or somewhat large, oblong, starchy root vegetable, right? A tuber, if you will. I can use more words in the language to describe what I mean in that language. This is how like natural languages work, and it's actually awful. Because in order to define what a potato is, I need to make reference to other words in the same language that would also need to be defined fully using other words in the same language. So all definitions in a natural language are ultimately circular, right? Which makes it difficult to reason in English, right? Some of you may have noticed this in your lives.
I noticed that teaching someone how to read and explaining what a word is.
Right? Yeah, no, it's like, oh man, like, maybe it's a good thing that the machines are gonna take over, right? Like, we're primates that have been forced into a situation that we were never designed for this, you know? A room full of blinky boxes, this is what we were designed for, that's okay. You know, but anyway, with computers, all computer language semantics are actually rooted in an objective meaning, and that is a sequence of CPU instructions, right? So the means by which you translate a programming language into the stuff that actually executes, that is the semantic translation of the code. That's what it means, that's what programming language semantics are. Does that make sense? Okay. So, why can't a compiler do this itself? The compiler cannot perform this check that objects should be replaceable with instances of their subtypes, right? Because the problem is undecidable, right? Undecidable for a mathematical process. Decidability versus undecidability is a computer science term for problems that cannot be solved algorithmically. Now, you know, you could be forgiven for thinking that computers can solve every problem, given, you know, or perhaps that's about as ridiculous as it sounds on the surface, right? There are certainly people who would think that a computer could solve every problem, particularly now in the age of the LLM, where, you know, your basic like low IQ take on LLMs is that they're actually thinking, right? So, you know, we've invented artificial brains. It's like, no, we haven't. But anyway. So, behavioral subtyping is trivially undecidable in general. So consider this. If Q is the property, method for X always terminates, right? It's impossible for a program to verify that this holds true for some subtype of S, even if Q does hold for T. So the whole problem, objects in a program should be replaceable with instances of their subtypes without altering the correctness of that problem. We have to break that down and say, what do we mean by correctness, right? One big aspect of correctness is, does the program terminate? Or is it an infinite loop? Or is it an infinite recursion? Something of this nature, right? So if the program doesn't ever finish, it's not correct. That's correctness. That's a correctness condition. Computers are not capable of calculating whether a computer program will terminate. This is like a fundamental result in mathematics, right? So it's got a name. It's called the halting problem, right? So basically the problem, the thing that causes the halting problem, right? In order to understand if the algorithm will take forever to terminate, you have to actually run the program forever, right? Because you can't run the program forever, you can't run the program that determines whether it runs forever because it itself runs forever. This is the halting problem, right? So because the halting problem is undecidable and it actually comes into correctness, program correctness, we can't actually verify correctness along these lines. Whose problem does it then become? Of yours. Right? You are the human brains. You can look at an algorithm and say, yeah, that's an infinite loop. That's a thing that the computer can't do. Right? Come on, Kevin, come on. We can also vet the principle as, we can also state that the principle is, let Q of x be a property provable about the objects of x type T, then Qy should be provable for objects y of type S, where S is a subtype of T. This is getting quite mathy, right? This is what I did for university, by the way. We can use formal proofs and related ideas, such as preconditions and postconditions, and invariants, to achieve the Liskov substitution principle. An invariant, oh man, I don't know. Next slide. You guys don't want to hear what formal methods are at 6:30 at night, right? Okay, very, very briefly, all right? The highest standard of proof in a discipline like this is mathematical proof of correctness. If you did like math, high school math, maybe they touched on this very briefly, but like geometric proof is usually the way that it gets introduced to people, right? You do things like, prove that prove that the angle XY, YXB is congruent to angle ZYB, right? Stuff like that. And it's like, okay, I apply this principle, I apply that principle, right? Via this result I get that. Via the law of parallel lines I get the angles are the same between this and that. And eventually you arrive at the conclusion, yes, this is true for all triangles, right? Similar processes can occur on software programming languages, although it's very, very, very difficult to do so. Trust me, I did this for 10 years of my life, right? There's a type of system that you can have called operational semantics. Operational semantics, right? Where basically your programming language is established as a series of substitution rules which are used for the purposes of evaluating expressions, and this is a formal mathematical system. You can write a program in this gibberish, and you can have this gibberish produce more gibberish, and that gibberish eventually proves that the system was had some property at the outset. Stuff like that. But this is like about as far away from the practical brass tacks of programming in sort of the modern, postmodern contemporary era as it's possible to be, so I'm not sure why it's on the slide. So, we can follow some heuristics to ensure adherence to the Liskov substitution principle. No new exceptions should be thrown by methods of the subtype, except where those exceptions themselves are subtypes of the exceptions thrown by the methods of the supertype. Did y'all catch that? Good. LSP issues. It's confusing. So, subtype polymorphism is okay to an extent, but there are problems. You might imagine that a square should be a subtype of a rectangle, right? Because a square is a rectangle with all of its sides equal, right? But this is a problem, right? Because if you're expecting the interface to be the same between the rectangle and the square, with a rectangle you can set length. You can imagine a class that allows you to set length and width separately, but that's not desirable with a square, right? So similar problems come up in many, many areas. And this is a kind of a problem inherent to object-oriented programming, which is difficult and unsolvable. So let's keep going. So, motivating the next, it would be nice if these slides were divided so that was yes and no. This one is motivating the next one. This is motivating the next principle. This is a different principle now, okay? All right? So, let's consider a vehicle. All right? All of these are necessary. Start engine, accelerate, brake, lights on, signal left, signal right, change gear, stop radio, eject CD. These are all of the things that you must do to drive a car, right? But maybe we want to maybe that's too much for one client, right? Maybe maybe you want to be the driver and be the one who's steering, etc. using the pedals, and maybe you want your co-pilot to be operating the radio, because it's dangerous for you to be operating the radio while driving a motor vehicle, actually. I actually got into my first and only car accident when I was fiddling with the radio. That's how that happened. It was very minor. Basically, it was one of these situations where you go through an intersection and then somebody does a hard stop to turn into the McDonald's that's immediately on the other side of the intersection. You guys ever seen this? I'm sure you've seen this before. But yeah, that was it. It got me. And of course I was driving a smart car, so basically what happened is the trailer hitch on the car in front of me just punched a hole in my plastic front panel and it had to be replaced, but that was it. So it goes. Anyway. With software taking over so much of the functionality of the average automobile, this may not even be a problem that doesn't exist anymore. This might be a real problem. I sure hope the car doesn't run Java. Interface segregation principle. No client should be forced to depend on methods they do not use. So basically, too many methods, too many different things going on, separate them into different interfaces so that they are, the grouping and the clustering is more tight, right? Implement ISP by splitting interfaces that are very large into smaller and more specific ones so that clients will only have to know about the methods that are of interest to them. This makes a system easier to maintain by decoupling the system and creating fewer dependencies. Very good. And now for our final principle. You guys excited? I'm excited. Dependency inversion. You heard about dependency injection? Well, now we are doing dependency inversion. So, depend upon abstractions, do not depend upon concretions. is a word. Alright. A hard, solid mass formed by the local accumulation of matter, especially within the body or mass of a sediment. I think that might not be quite what that word means. The idea that a concretion is a unit of thing which is opposite to an abstraction. It's like abstract versus concrete, abstraction versus concretion. Ooh. So, more detailed version. High-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. This thinking inverts how one traditionally thinks of object-oriented development. Normally, we think of lower layer components being used by higher layer mechanisms to carry out functionality. The problem arises when we want to change a lower layer, the problem arises when a change to lower layer then requires changes to the higher layer. Problems arise when a change to the lower layer requires changes to the lower layer then require changes to the higher layer. Okay, I think we've got the wrong then. We have than instead of then. So, use interfaces to invert dependencies. So, rather than having just a direct sequence of that, we make this an interface, the policy service. The policy layer implements this. This then inherits the interface, the mechanism. The mechanism itself has an interface which it's implementing, and then the utility layer is inheriting that. Are these the arrows that I think they are? I feel like these are being used in a way that's non-conformant with the Java course.
Maybe it means depends upon and not inherited, right?
Depends upon? Yeah. I mean, it would be useful to have a legend.
There is a source for the depends upon.
Oh, that's true, yeah.
Oh.
Useful! Ba-da-ba-ba-da-ba. Where did it go? Oh man. I'm really trying, guys. You can feel it, I'm sure. Alright. The result is not that lower layers now depend on higher layers. The word invert may lead you to think of this. The result is that both the lower layer and the higher layer depend on an abstraction. They should both depend on abstractions. The result is that we can modify the lower level details, and as long as we conform to the common abstraction, higher level classes do not require modification. So basically, if you take your API, you solidify it as something that needs to be type checked, as long as both people agree that they're still using the same API, everything's cool. Make sense? So, solid principles. Powerful when used in unison. End result code is code that is well modularized and easy to modify and extend. As with all principles, though, we don't want to turn off our brains and follow them in a rote way. We should balance their application with other principles and other concerns, like perhaps preserving our 3 remaining neurons for exams. So, any questions? All right, now do me a solid and get out of here. Class is dismissed.